students in my second lecture of the differentiation. Today we are going to learn about the rules of the differentiation. We are seeing what are the rules of the differentiation. Let us take as a if u and v are differentiable functions. Differentiable functions such that first u plus v. For this addition we take the variable as y. These two functions u and v are differentiable functions with respect to x. Then we have to find the derivative of this y with respect to x. Then what is the rule for this? That is dy by dx means the variable y and differentiation of y is dy by dx. Then the rule is dv upon dx plus du upon dx plus dv upon dx. This is the first rule of the differentiation of addition of two variables. Such like we can take for this as subtraction. When y is equal to u minus v, then the rule is dy by dx is equal to du upon dx minus dv upon dx. This is the rule for the addition and subtraction also. Now taking the second rule for the product of the two functions. What is the rule for the product of the function? That is y is equal to u dot v means product of the two functions u into v. Then we take this product as a y. Then differentiating this y with respect to x. Then we get dy by dx is equal to, take first function as u and take the derivative of the second function, that is dv upon dx, plus take the second function as and take the derivative of the first function du upon dx. This is the rule for the product of the two functions which are differentiable functions of x. That is y is equal to u dot v dy by dx is equal to, keep the first function as it is and take the derivative of the second function, plus keep the second function as it is and take the derivative of the first function. Okay, clear it? Take it as. Now we are going to the third rule for the differentiation. That is y is equal to u upon v. Then taking the derivative dy by dx. U upon v. This is u is a numerator and v is a denominator. Then take the first as denominator and take the derivative of the numerator, that is du upon dx. Keep the denominator as it is and take the derivative of the numerator, that is du upon dx, minus keep the numerator u as it is and take the derivative of the denominator, that is v dv upon dx, divided by v square, where v is not equal to 0. After seeing these rules, we take some examples on these rules. First example. Suppose f of x is equal to given as 5x plus 3. Then take the derivative of this function, suppose y is equal to f of x, then we take its derivative as dy by dx and write as differentiate y with respect to x. Dy by dx is equal to f dash of x, that is equal to, the function is 5x plus 3. Then keep this 5 as it is. This 5 is a coefficient of the variable. Therefore, keep as it is and take the derivative of x is 1 plus 3. That is the constant. Derivative of this constant is 0. How we can take this derivative? By using the first rule, that is u plus v. Suppose this first function is u and second function is v. An addition of these two functions, and by using the addition of two functions, we use the rule of the addition of the functions and differentiate it. Okay, taking the next example again. Question is like as that. Suppose we have to give one as function sin x plus log x. Then differentiate y with respect to x. Using the addition rule, then differentiating this y with respect to x, it is written as dy by dx. Then using the first rule, that is for the addition of two functions, that is first function is sin of x. Taking the derivative of sin x, we take it as d by dx of sin x plus d by dx of log of x. dy by dx is equal to, we have studied already all the derivatives of the standard functions using these formulas for this derivative. Derivative of this sin x is equal to cos of x plus derivative of log of x is equal to 1 upon x. dy by dx is equal to cos x plus 1 upon x. This is the answer of this. Okay. We have studied that how to use the rule for the addition of two given functions which are differentiable functions of x. Again one of the example, second example for this rule, that is, suppose y is equal to x square into e raised to, plus addition of two functions x square plus e raised to x. Taking derivative of these two functions which are given as addition of two functions. Differentiate y with respect to x. We get y as dy by dx is equal to d by dx of the first function, that is x square, plus d by dx of e raised to x. Then using the formula, standard formulas for the functions, that is x raised to n formula. For this, derivative of x raised to n, that is equal to n into x raised to n minus 1. For n, we get this value as 2. Then use the formula, that is 2. For n, we take it as 2 x raised to 2 minus 1 plus derivative of e raised to x is e raised to x. That is equal to 2 into x raised to 2 minus 1, that is x raised to 1 plus e raised to x. That is equal to 2x plus e raised to x. That is derivative of the given functions. Addition of two functions. Now we are taking some examples for the product. By using the product rule, we can differentiate the given functions. Okay. Suppose example, y is equal to x into sin x. This is given as like product of the two functions. First function u and second function v. Suppose then differentiate y with respect to x. Differentiate y with respect to x. For every example we write this line. Okay, this compulsory. Then y becomes dy by dx. Then using the rule for the product of the differentiation, then keep the first function as it is, that is x, keep as it is, and take the derivative of sin x, d by dx of sin x, plus keep the second function as it is and take the derivative of the first function, that is x, is equal to x into derivative of sin x is cos x, that is by using the derivatives of the standard formula, plus sin of x and derivative of x is 1. And answer is x into cos of x plus sin of x. This is the derivative of product of the two given functions. Go through this example. I will take the differentiation of the quotient by using the quotient rule of the differentiation. The second example for the product rule. Second example for the product rule. Y is equal to, suppose, e raised to x into sin x. Taking the differentiation of y with respect to x, we get it as dy by dx is equal to, keep the first function as it is, that is e raised to x, derivative of the second function means the derivative of sin x with respect to x, plus keep sin x as it is means the keep second function as it is and take the derivative of e raised to x, that is equal to e raised to x into derivative of sin x by using the standard formulas. Derivative of sin x is cos x, plus sin of x as it is and take the derivative of e raised to x as e raised to x. Then by simplifying we get e raised to x common from these two, cos x plus sin x in the bracket. This is the derivative of the product by using the product rule for the differentiation. Go through this example, take down it. Now we are going to see the quotient rule for the differentiation. What is the quotient rule? What is the quotient? It is given as like that. Suppose we are given that u upon v, like as y is equal to sin x upon log of x. Suppose this is the numerator and This is the denominator. By using formula for the quotient, differentiate y with respect to x. We get dy by dx is equal to, keep the denominator is log of x. Keep the denominator log of x as it is and take the derivative of sin of x. Minus, keep sin x as it is and take the derivative of log of x divided by v square. What is v? V is a log of x. dy by dx is equal to v square divided, that is log of x bracket square. And taking the derivatives of these functions, log of x keep as it is means the denominator keep as it is and take the derivative of sin x is cos of x. Keep sin x as it is and take the derivative of log of x, that is 1 upon x divided by log of x bracket square. This is the derivative of quotient. Go through this example and write down it. I will take the second example. One more example. One more example. Suppose y is equal to x square upon e raised to x. Then differentiating this y with respect to x by using the quotient rule, y with respect to x by using the quotient rule, that is dy by dx is equal to, keep the denominator as it is, denominator is e raised to x and derivative of x square, that is d by dx of x square, minus, then keep x square as it is and take the derivative of the numerator, that is e raised to x divided by v square. V means the denominator, that is e raised to x bracket square. Keep denominator as it is, take the derivative of the numerator, that is x square, minus keep numerator as it is and take the derivative of the denominator divided by v square. V means the denominator, that is e raised to x bracket square. Then taking the derivatives by using the standard formula, that is e raised to x into derivative of x square is 2x minus x square into derivative of e raised to x is e raised to x divided by e raised to x bracket square. This is the derivative by using the quotient rule of the functions. Take this example, write down. Okay students, we are going through the rules of the differentiation, coming up to the next lecture. Up to next lecture, goodbye and good day.